In this video, you will learn about different types of pairs of angles. So let's jump right in. First, we have complementary angles. Complementary angles are two angles whose sum is 90 degrees. All right, so you need two angles adding to 90. So for example, in this picture right here, we see that angle A is 40 degrees and angle C is 50 degrees. So if you add 40 and 50 together, you get 90 degrees, which means that those two angles are complementary. So we'd say angle, and I guess technically we'd name this as BAC, this angle right here. Angle BAC and BCA, that angle right there, are complementary. Now you might be wondering, well, what about angle ABC? This is 90 degrees, right? Well, by definition, we need two angles adding to 90. So this is just one angle that is exactly 90, but by definition, we need two angles adding to 90. Here's another example. We see two angles, one being 30 degrees, and then this one is 60 degrees. So 30 plus 60 is 90. So these two angles are complementary. So we would name this first angle as angle DEG. Then the other angle is angle GEF. So those two angles are complementary. Now if you're given the measure of an angle, let's say angle A, and that measure of the angle is 43 degrees. So the M, by the way, means measure. So the measure of the angle is 43. If you were given this information and you were told to find the complement, or the measure of the complement, we know that a complement or complementary angles would add to be 90. So we have some angle, we'll call that C, plus 43 would give me 90 degrees total. So the question is, what plus 43 would be 90? Well, to figure that out, we just subtract 43. So we now have C equals 90 minus 43, which would be 47 degrees. So the measure of the complement of angle A would be 47 degrees. Next we have supplementary angles. Supplementary angles are two angles whose sum is 180. So similar to complementary, except here they add to be 180 instead of 90. So for example, here we have two angles. The first one is 120, the second one is 60. Notice if I add 120 plus 60, I would get 180. So these two angles are supplementary. So we would say that angle ABC and angle GEF are supplementary angles. Here's another picture. We have two angles. One is 150, the other is 30. Notice again, these would add to be 180. So this angle HJL right here and angle LJK right here, those two angles are supplementary. Now if you were given the measure of angle A to be 43 degrees and you were told to find the measure of the supplement of angle A, well, I know that the supplement will add with this to equal 180. Right? That's your definition of supplementary. Two angles adding to 180. So what angle plus 43 would equal 180? Well, to find that, I just take 180 minus 43, which would give me 137 degrees. So the measure of the supplement of angle A is 137. Our next type of pairs of angles are what are called vertical angles. Now what vertical angles are two angles that are across from each other. All right, so we see here the red angles, so 3 and 4. All right, those angles are vertical. Then angles 1 and 2 are vertical. Now a more technical definition are two angles such that the sides of one angle are opposite rays to the sides of the other angle. So if you don't quite understand that, let me illustrate. Here we have angle 1 is made up of this line, right? It's this ray, and then this ray. Okay? So if I take a look at this one right here, the opposite ray would be going in the opposite direction, which would be right here. And then this ray, the opposite ray, would be right here. And so we have those two rays created from the opposites of the original, and that creates this angle right here. And it's across from it, and it shares this vertex right here in the middle. Alright, so 1 and 2 are vertical, 3 and 4 would also be vertical for the same reason. So here is a more complicated picture, and we are to find the vertical angle to angle 1. So looking at angle 1 right here, this is my angle. Now if I extend this one ray to create the opposite ray, we would get this right here. If I extend this ray in the opposite direction, we would get this ray over here. So notice we've created this other angle right there. So 1 and 4, those are opposite because they're across from each other. So the vertical angle to angle 1 is angle 4. If that is still not clear, let's try another example. Find the vertical angle to angle 5. So angle 5 is right here. Right? It's going to be created by this ray and then this ray. If I extend both of those rays, we would have this ray right here and then this ray right here. So notice that when we did that, we have created angle 2 on this side, and that's across from angle 5. So the vertical angle to angle 5 would be angle 2. Okay, let's try one more example. Find the vertical angle to angle 3. So angle 3 is created by this ray and this ray. If I extend both those rays, I would have here and here. Okay, so notice the angle I created was this angle over here, angle 6. Angle 6 is across from angle 3, so angle 6 is my vertical angle. Now we're going to pause for a moment with our discussion of pairs of angles, and we are going to discuss parallel lines. The reason for this is because we are building so that we can talk about different types of pairs of angles. But to get to that point, we need to understand what parallel lines mean. Parallel lines, by definition, are lines on the same plane that do not intersect. So coplanar means lines on the same plane and they cannot intersect. So for example, right here, these two lines are parallel because they do not intersect. And the symbol is going to be two vertical lines like this. Right, it's two vertical line segments. It looks like two L's. This is my symbol for parallel. Next we have the term intersecting lines, which are lines that cross each other. So for example, right here would be two intersecting lines. So parallel lines never intersect, whereas intersecting lines do intersect. So now we're going to combine those two different ideas of parallel and intersecting lines. Here we have what is called a transversal. A transversal is a line that intersects two or more coplanar lines in different points. So see this red line for each of these pictures? Those red lines are what are called transversals because they're crossing over two other lines. Okay? So that now leads us to this next picture over here, where we have two lines and a transversal, this red line, cutting through. Now with this picture, we have different pairs of angles. So we see these angles numbered or named with the numbers 1, 2, 3, 4, 5, 6, 7, 8. Those are the angles that are created from the two lines and the transversal cutting through. First we have what is called interior angles. So interior, by definition, is something on the inside. Now, interior angles are inside of something. Well, what are they inside of? Well, what they're inside of is they're inside of these two blue lines that are not the transversal. So if you look on the inside, we would have angles 3, 4, 5, and 6. So that would be my interior angles. Exterior angles are angles on the outside. So on the outside of these two blue lines. So on the outside, that would be angles 1, 2, 7, and 8. Next we have what are called alternate interior angles. So these are angles on the inside that are on alternate sides of the transversal, meaning they're on different sides of the transversal. And more specifically, they're on opposite sides but cannot be touching each other. So for example, we have angle 3. An alternate interior angle to angle 3 would be an angle on the inside of the blue lines and on the opposite side of this transversal, this red line. And it cannot be touching, which would mean it has to be the 6 over here. Those are alternate interior angles. They're both inside the blue lines and they're on different sides of the transversal and not touching. So those would be two alternate interior angles. So angle 3 and angle 6. Looking at angle 4, an alternate interior angle to angle 4 would be angle 5. They're both inside the blue lines and they're on opposite sides of the transversal, this red line, and they do not touch each other. So angle 4 and angle 5 would be considered alternate interior angles. Next we have alternate exterior angles. So same exact idea. These are two non-adjacent exterior angles on opposite sides of the transversal. Non-adjacent just means that they're not touching. So they are exterior angles, so we're looking at 1, 2, 7, and 8. And they're on opposite sides of the transversal. So looking at angle 1 right here, an alternate exterior angle would be angle 8 over here. They're both outside of the two blue lines, and they're on opposite sides of this transversal, the red line, and they are not touching each other as well. Alright, so angle 1 and angle 8 would be alternate exterior angles. Looking at angle 2, right here, an alternate exterior angle would be angle 7. They're both on the outside of the two blue lines, and they're on opposite sides of this red transversal. So angle 2 and angle 7 would be considered alternate exterior angles. Next we have same side interior angles. So same side is really what it sounds like. It's on the same side of the transversal. So looking at angle 3, for example, a same side interior angle would have to be angle 5 because they're both interior, they're both inside, and they're both on the left side of this red transversal. So angle 3 and angle 5 would be same side interior. Same thing with 4 and 6. Angle 4 and angle 6 would be same side interior as well. And then we have same side exterior angles, which are two exterior angles on the same side of the transversal. So for example, looking at angle 1, angle 7 is exterior and is on the left side, the same side as the angle 1. So therefore, angle 1 and angle 7 are same side exterior angles. And then looking at angle 2 and angle 8 would be same side exterior because they're both outside the two blue lines and they're both on the same side of the transversal. So angle 2 and angle 8 would be same side exterior angles. Okay, next we have corresponding angles. Corresponding angles are two angles in corresponding positions relative to the two lines. So it's helpful if you look here at these four angles as being one pair, one set. Over here is another set of angles. So looking at angle 1 up here, notice angle 1 is in the top left. So looking at these four angles, angle 1 is the top left of these four. Down here, angle 5 is the top left of these four. so angle 1 and angle 5 are corresponding. Angle 2 is in the top right, angle 6 is in the top right, so angle 2 and angle 6 are corresponding. And then 3 is in the bottom left, 7 is bottom left, so angle 3 and angle 7 are corresponding. And then we have 4 and 8 both on the bottom right, so those are also corresponding. So in all of these pictures, these two blue lines were not parallel, right? They're going to intersect way down here at some point. So in the next few examples, we're going to deal with specifically parallel lines. And with parallel lines, there are some properties that will be true with different pairs of angles. So here we see our picture. We have two parallel lines and then a transversal cutting through. And again, we have 8 different angles that are created. Now with parallel lines and a transversal cutting through, some things are going to be true. The first thing is that the corresponding angles will be congruent. So the corresponding angles would be like angle 1 and angle 5. Those are both in the top left. Angle 1 and 5 would be congruent. Angle 2 and 6 would be congruent. 3 and 7, both in the bottom left, would be congruent. And angle 4 and angle 8 on the bottom right would be congruent. What's also true is that the alternate interior angles are congruent. So alternate interior angles would be things like 3 and 6. They're both inside and on opposite sides of the transversal. So 3 and 6 would be congruent, and then 4 and 5 would be congruent as well. And by the way, when we say congruent, what we mean is that the angle measures are the same. So like if angle 3 was, let's say, 100 degrees, angle 6 would also be 100 degrees. Another property is that the alternate exterior angles will also be congruent. So for example, angle 1 and angle 8. Those are alternate exterior angles. So those would be congruent, and angle 2 and angle 7, which are also alternate exterior angles, will also be congruent. Now with this information, I can use these 3 different properties to determine the missing angle measure. So for example, if we are told that the measure of angle 2 is 105 degrees, we could find all the other angles based off this information. So if angle 2 is 105 degrees, we can use this because we know that the corresponding angles will be the same. So if this is 105, then angle 6, which is also corresponding, would be 105 degrees as well. All right. We also know that alternate interior angles are the same. So angle 3 and angle 6 both would be 105 degrees. We know that alternate exterior angles are the same. So looking here at angle 2, the alternate exterior angle to angle 2 is going to be angle 7. So that would also be 105 degrees. So the question is, what are the other angle measures? Well, if you take a look here, let's say at angle 1 and angle 2. Okay, if you put these two together, notice we have this line created. Well, a line is a straight angle, and a straight angle has 180 degrees. So if I take 180 minus the 105, that means angle 1 has to be 75 degrees. And for all the same reasons, we can figure out these other angles, and these would all be 75 degrees as well. So this is 75, this is 75, angle 4 is 75 degrees. So based off just this one angle measure, we can find all the other angle measures based off those 3 different properties. And those properties again are the corresponding angles are the same, the alternate interior angles are the same, and then the alternate exterior angles will be the same. And that concludes our lesson for today. We will see you next time.